become the third session moderator. The third session will be the environmental engineering, and the moderator is Dr. Sanhui Oh, Professor Emeritus and National Cheng-Kung University.
Well, good morning, everybody. Today seems less participant. I'm Oh Seng-Chuan. I work as a university professor for 40 years, but now I'm retired. Yeah. So today in this section we have one keynote speech and five poster. Quite paper presentation. So I have pleasure as the moderator. Our keynote speaker is Seng-Chuan. He's an important person in the engineering society, not only in informatics, but also in international engineering society. Yeah. So he graduated from National University of Singapore, Faculty of Civil Engineering, and also obtained a postgraduate diploma in building science and a Master of Science. He was past president of Institute of Engineers Singapore, and also past president of Freedom. 4 years ago. And he is now the vice president of WFEO and also the deputy chairman of FA Engineering Coordinating Committee. I heard he will be the new chairman of the FA Engineering Coordinating Committee. Okay, he is the professional engineer registered in Singapore and also a chapter professional Institution of Engineering Singapore, also registered in Australia, and also ASEAN chapter professional engineers. Also, he also is a fellow of the Institution of Engineering Singapore and also Engineer Australia. He also is a honorary fellow of the ASEAN Federation of Engineering Operations. And also he served in the WFEO as a member of Strategy Plan Test Group, also WFEO UN Relations Committee, and vice chair of the WFEO Committee on Engineering and Environmental. Also, besides contribute to the local and international engineering committee, Engineering Town was appointed by the Singapore Medical Council to serve as a member of the Disciplinary and Complaint Committee from 2004 to 2010. And he also served in the Inquiry Panel of Law Society of Singapore since 2009 to 9. So let's welcome Engineer Tan.
I hope you sleep well last night. Some may be not able to wake up this morning. Today I presented on the WFEO model code of practice. I'm in the Committee for Environment, Engineering and Environmental in WFEO. So I thought we have spent a lot of time in drafting out this model code of practice. Our objective is to disseminate the information to all our engineering community. Hopefully, our community can able to use it as a practice in terms of your project development. All right. A lot of time, engineers doing their projects, you take up your design code of practice and then start to work on it. It's just like some of my engineers say. All right. So it's looking at the project very silently. So what we wanted to do is to promote the engineer look at the bigger perspective. How does it, how the project is going to affect the environmental aspect, economic aspect, social aspect, before you decide on the projects. Right. So that's the whole objective of this. This presentation is created by Engineer Canada. I got to give them an acknowledgement, and I'm the vice chair for that committee. And I promise them that we'll use whatever platforms we promote this code of practice, and hopefully you understand what we do in WFEO. Okay. Of course, there are larger journey for WFEO to go further. Yesterday, in the dinner, he already promoted Kyoto Convention, right? So we hope we can see more people over there to support our colleagues in Japan. Okay, so let me go through it. I'll just go through it. I only have 20 over slides, so since the audience are not that big, we can have more communications. And if you have any questions, please interrupt me and ask questions if you need any clarifications. All right? Sustainable development. A number of people is talking about sustainable development. But what is it sustainable? So under one of these Prudent Commission reports, they define sustainable development is development that meet the social, economic, and environmental needs of the present. So probably you hear many times without compromising the ability of future generations to meet their needs. So we are not going to use we're trying to look at the present conditions without utilizing the future resources. So this is, we call it sustainable, right? Otherwise, if you start into future resources, then it's just like your bank account, right? You start to take out your saving, so you can't survive in the next half of your life, right? So it's the same thing. So what we're trying to do is how to minimize our waste and maximize our products. So what the engineers can do in this sustainable development, what technology is one of our strengths, right? So we have a lot of idea on how to innovate our technology, how to create technologies to solve the problem. And actually, from what I see, all this theory is quite simple. It's not complicated. What we need to do is think of more holistic view to look at individual issue and integrate them together and find solutions. Right. So just like I say, a lot of time we are just too narrow-minded. So what we need to do for engineers is to having a more holistic view, looking at different solutions, and then come up with an optimal solutions to the problems. right? So environmental stewardships. Under the definitions, what it says is environmental stewardship is the prudent use of the finite resources in nature to produce greatest benefits while maintaining a healthy environment for the foreseeable future. As just how I mentioned, we have a limited resources. We don't want to use the future resources, and this is where the engineers are able to steward the how to use our resources in our design, and then to produce the product or the projects you are developing. So human society is part of the environment. Protecting and enhancing environment is good for the society. So what is why we need to bring the human factor into our project consideration? Because as engineers, we just need to look at technologies. Why we need to look at human factor? I started my career in civil engineering. So at that time, following the codes. In Singapore, we use BS codes. We started with BS 449, and then CT 110, and then 5950, and all those things, right? But probably more than 15 years ago, I get into the environmental area and start to understand how important is this. Based on the design codes, we just come up with our reinforcement, steel structure, framework, but how does it impact in our environment? And in the environmental sector, before we start the projects, we need to look at the impact to the environment. Probably you heard about, I think in Taiwan, you also work on the environmental impact assessment, right? So when you work on the impact assessment, you look at different possible impact to the environment. But in few years ago, probably from my understanding, probably this is first time Thailand has came up with regulations to look at the social and health aspect of the impact. So I thought that is a good thing to promote. Is you are not only looking at how your project will affect the environment, the project will also affect human and health, right? So, for example, if you do an incineration plant, you want to control the emissions, and in Singapore we don't have incineration plant because we don't have landfill, right? In Taiwan, possible, but a lot of countries they ban for building incineration plant. I'm not sure Taiwan is one of them, but I think quite a number of countries I encounter, they say they can't have incineration plant. Their waste is going to landfill. So when you have an incineration plant, you need technology to look at whether the emission level, how does it impact the people, right? And then after that, you need to look at the waste generated from the incineration plant. In Singapore, we are also looking at how to utilize the fly ash and the bottom ash, right? I think a lot of people know that fly ash we mix with concrete, use of building material, right? What about bottom ash? It's toxic material. So how are we going to use it? Are we putting it into the ground, or how do we handle it? So these are some of the issues. Not just building an incineration plant, you are solving the problems of the waste, but the subsequent issue, how are you going to handle, right? Another example, I do a number of wastewater treatment plant, right? So after you treat the water, you got to clean water, you discharge the drain. That's not all, because what happened to your compost? The waste, some may turn into compost, and now we are looking at Singapore is an urbanized country, right? So we don't go to the agriculture. So what we do is how to turn it into energy. So that is another challenge, right? So maybe some of you all heard about waste to energy. So this is what we are trying to do, is how to be efficiently use the waste and turning into energy, and then generate power to support the plant. So become a self-sufficient. Sometimes you even can supply to the grid. So these are the engineering challenge. But what I want to demonstrate is we need to look at the total solutions. We are not looking at just engineering itself. All right. So environmental factor, health factor, human factor, social factor. All right. Social. I give you an example. Resettlement of people. If you have a project and then you locate it in certain area where the residents are there, how are you going to resettle the people? And it's a very complicated issue. So when you do the feasibility study at that time, you need to look into resettlement issue. And it's not just only paying money, because people staying there for a long time, their roots are there. So how are you going to get them to move to for your developments? So community issue. So these are the issues that we normally need to consider in our development. Otherwise, you put in the money, you never get return. Right? Okay. So what we are promoting is sustainable development and environmental stewardship will link up together. So you consider the aspect under the US EPA, it mentions that effective environmental stewardship requires all of us to manage natural resources in a way that protect and enhance rather than compromise the ability for future generations to meet their own needs. All right, so that is the very important to when you develop all your projects. Right. So the environmental stewardship and sustainable development to meet the present and carry forwards together. We can't do it one in front, one behind, because you need to justify your investment costs. And for business, money is very important, right? So whatever investment you put it in, you want to make sure that there's a return coming in. So you need to consider all this in order not to give you surprises. All right, you can hear many projects after they develop, proposed by the community, and then you got to stop work there. There's a plant in Malaysia, low radioactive material. They're treating the radioactive material, and because the plant is being built, the approval is being obtained. But before the plant starts, the community protests. So, what are you going to do? All right. So these are the considerations you need to look into it. We have a good technology, but no use. What you say is 英雄无用武之地, right? So consider the aspect of environmental stewardships, and then you try to see how to identify the problem, mitigate the issue, and manage the implementations. In WFEO, we are focusing two areas, right, where the engineers mostly involved. One is design and build projects that meet basic human needs, right? And then the other area we are looking at is the design and build facility and system to mitigate environmental factors. So we are, the committee is looking at various aspects of the issue and also helping our members to find solutions to that. And we normally discuss about that annually. Yeah? And hopefully we are able to help our engineers on certain issues they encounter in their own countries. So what we say is engineering profession is neutral. So engineering is just a process of practicing what you have learned. But engineering projects are not neutral. Why we say that? Because there are other issues, political issues coming in, political factors coming in, right? When you generate a project, human factor coming in, economic factor coming in, your budget constraint. So you normally bias or steer into a certain directions. So this is not neutral, and we need to manage. Of course, for engineers, unless you're a developer, otherwise you can't, not able to make decisions. But our role is to educate the developer, provide sufficient information to advise the developers on the pros and cons of the decisions. And that's, we have done our duty. Of course, if we convince them, that will be better. So our role is not just only design, but our role is to make sure that we take up the environmental stewardships and make sure that the projects are, developments are being taken care of. So engineers are faced, there's a dilemma we are facing, and may not be a decision maker. They may share the perspective of the local community. So this is our duty to advise the stakeholder, the pro and con regarding sensitivity to the local community, providing robust information to decision maker, assuming leadership role when the opportunity are present. All right, so this is what we have discussed just now, and this is what we want to pass down. The message is think global, act local. All right, so that we need to think more on the holistic view, and then you focus on how the project is being developed. We have came up with the code principle, 10 principle. I'll just go through the 10 principles very briefly. Of course, one is knowledge and competency for engineers. Limits to competency. Engineers, we have a quite wide area, so we don't. We must know where's our limit, right? We cannot do everything by ourselves. And then the social impact, as I mentioned, sustainability outcome, cost and economy, right? From my experience, that's probably the weakest points of engineers. A lot of times, my people, they work very hard, they deliver the projects, but at the end of the day, my balance sheet got problem because they don't collect money. They won't ask the client for money. They just, whatever the client asks, they will just give. Alright? So this is financially, I think engineers not very good with. maybe that related to our training as well. Planning and management, innovations, communications, and consultation. Communication is another problems from the engineering community. Normally we just want to do our work, but we forgot to communicate with the stakeholder, and that caused certain misunderstanding, and that caused problems. So communications is one of the important criteria. Regulatory and legal requirements and risk mitigation. Risk is another aspect that a number of our engineers. So I only have 5 more minutes to go. So let me run through the 10 competency. The knowledge, I think this one I just need to explain, maintain and continue to improve the awareness and understanding of environmental stewardship and sustainable principle. All right. Limit to competency, as I say, certain area we may not be good at, but please hire your counterparts or other professionals to fill up the gaps. Don't pretend that we know everything. It's part of the professional ethics, right? I think it applies in all countries. Social impact, incorporate global, regional, and local societal value applicable to your work. So need to look into the regional impact, the local impact, especially cross-border. We have a number of cross-border issues, and that is what I mean in terms of certain social impact. You need to consider the cultural difference. All right. And then the sustainability outcome. Implement sustainability outcome that's the earlier possible, stage employing all applicable standards and criteria. So that is predicts what is the sustainable outcome. For example, carry out the impact assessment, understanding what are the problems, mitigate the issues. Costing and economic. As I mentioned, you need to have various options of advising the stakeholder. But some may say that this is not my jobs, accountant's jobs. But engineers know well on technologies, know well on the project itself. So even it's not our jobs, we also need to have a holistic view on what is the numbers going to be like. Planning and management, and this is what we are trying to say, that we need to consider the life cycle planning. Life cycle, okay, I emphasize life cycle is from beginning of the project to the end of the project. All right. So sometimes when we do carbon footprint, we do need to look into supply chain. All right. So I can talk a bit more about the supply chain issue because we also encounter a number of issues when people saying that I have a reduce the carbon footprint, but are you sure you are really reduce the carbon footprint? Because do you know that in your supply chain they are doing the same thing as what you are doing? Right. So there's many other things to talk about carbon footprint. Innovation. This is the strength of engineers. Innovate, but while doing innovations, you do need to provide alternative, not just only one solution. The better is a few solutions, and you find what is the optimal solutions to the problems. Communication and consultations. As I mentioned before, one of the weaknesses is communicate with. Even now, with your mobile phone, we do a lot of WhatsApp, right? So even engineers sit next to it, they don't communicate. They use WhatsApp or the phone, right? So human communication. Why we need to be here? Because we want a face-to-face discussion, and that would be easier to solve the problem rather than you are using email. Right? So certain level of human touch is still important. Regulatory and legal requirement. This is every country or every economy do have their regular legal requirements. But on the other hand, also need to look into the global requirements, right? So probably in the environmental sector, you know that COP21 is coming up in Paris. So what is COP21? What are they going to discuss, and what are the outcomes? And whatever decision over there is going to impact to your own operation in your own countries. So these are some of the things that engineers do need to understand what's happening outside of your own countries. Risk mitigations. Risk is a lot of engineers are looking into their own projects. Sometimes when I ask some of my fellow colleagues to see what is your contractual risk, they don't know. Because I never look at contract, it's not my problem. My job is only design. So contractual risk is it's a very important to the whole project, right? So how does it impact? And it's not only your whole company can collapse because there are certain words missing in your contracts. So that is one of the very obvious reasons. Of course, technology risk is also another one in the projects. So one of my job is to look at review. When I review the engineer's design, I always look at the risk aspect and what are the how to mitigate the risk. Are we able to manage the risk? So this is another area we need to look into it. And I believe that is the last one. So that is So that is the last one. What we want to do is engineers can work towards a better solutions and contribute to the profession ability to promote sustainability and environmental stewardships. All right. So this is the message we want to get across, and David is the one who helped us to write this, and we have translated into different languages. I've asked my colleagues to translate into Chinese because China market is a big market, and last year we have just published the Chinese version, but now I think we have 5 or 6 languages. Okay, thank you very much.
Engineer Tang, for very important and also excellent presentation. Okay, thank you.
Yes, I would like to ask you to stay for a moment for the CIE have a gift for you for your. We ask Dr. John Lee to go off the stage. Thank you.